Welcome back to AI Renaissance with Rena. Today we're talking about democratizing AI with impact to the world economy. Today we have Sergio Leon, who is a software engineer and entrepreneur impacting the tech community here in Miami. Serge is working on a lot of cool apps that he can talk about today, and he has a background in electrical engineering. Serge the Lion, tell us how you're feeling today.
I'm feeling welcome and happy to be here. Thank you. Yes. Well, you mentioned I haven't described myself as an electrical engineer for a long time. But yeah, telecom engineering, actually.
Yeah. But you got the tattoo, the Fourier
I
transform.
have a Fourier transform tattooed on my arm. Yeah, funny story. Freshman year, telecom engineering in Havana. This is like they throw you at the math that's behind this crazy thing, and you either get it or you are out. Like you either get it or you don't, because you never stop seeing it after.
Yes, the minimum requirement is you must know Fourier transforms.
It's weird. I would not throw freshman year students at it, just because it's deep.
Sometimes you do the hard thing, so everything else is easy after that.
Yeah, eat the frog.
Eat the frog. There you go. Well, I'd like to start a tradition on this podcast where we have each guest define AI in their own words. So let's define intelligence and artificial intelligence.
Ooh, interesting. Okay, so the way that I think of intelligence in general is the ability of an entity, a human, a robot, software, to have knowledge of self. So you have something that is aware that it exists in the world, and it's aware to perceive. It's able to perceive itself. Definitely not the way that many people think about intelligence, but I think it enables other really interesting things.
So self-awareness is your requirement to even be in the field of intelligence.
Yeah.
Okay, I like it.
It's a minimum. It's not necessarily sufficient because you have animals that are self-sufficient.
Animals.
Right?
Yeah, so let's look for animals that we think are not self-aware, or are they all self-aware?
I don't know. I'm not a biologist, but I don't know that bacteria are self-aware. I don't know if viruses are self-aware. You would find, or I have found people, or I've heard people describe these things as alive, and right, like forms of life, bacteria, viruses.
But maybe self-awareness can be thought of as an organism, if we're talking about organic life, organisms that have some goal that they're working towards. Like squirrels are just trying to get nuts to eat. That means they have a goal, so they must be self-aware that they are hungry, they need that thing.
I definitely think that being goal-oriented or goal-driven is in there in the mix, but I also wouldn't think that is what defines intelligence, because viruses have goals. Viruses, their goal is to replicate their genetic sequence, right? And they'll infect a cell and just hijack it for the reproduction of its genetic material. And so they're very goal-driven. They're
goal-driven, but you're saying they're lacking self-awareness.
Yeah, like the ability to introspect, right? So the ability to think about self.
Okay, that's the part, introspecting, thinking about yourself.
Mm-hmm.
I would say a squirrel is thinking about themselves, but now I'm thinking about viruses and bacteria. I mean, people never really agree with my very niche views of AI. I think that a small insect, I think bacteria, I think a remote control is intelligent.
Oh,
because it's processing information and transforming it into new information.
Mm-hmm.
But you have a cutoff point where you're like, no, viruses and bacteria are not going to be considered intelligence for the definition that you will describe.
Yeah.
Okay.
It's like a squirrel is definitely intelligent. It's not as intelligent as a chimpanzee, but it is aware of itself.
Yeah. Okay, so you have a definition of intelligence, which we have used organic creatures to define, and now we'd like to define artificial intelligence.
To me, that's the simplest part, right? If it was not a product of organic chemistry in this planet or some other planet, right? If it was manufactured, then I would think that it's artificial.
Okay. So obviously computers are manufactured. We know that everyone agrees they are AI. but let's get into the details there. Like, what would let you say this is artificial intelligence?
Well, first off, computers are rocks that we taught how to process information.
Rocks.
Yeah,
They're just
silicon.
rocks.
Yeah, they're rocks. They're smart rocks, right?
We made them smart, actually.
Yeah, we made them very capable to do dumb things really, really fast.
Yeah, so we don't have to do those things.
Yeah.
Yeah.
So computers are told, to the extent that we know human made, I have not seen, I don't think that anybody would disagree with this. I have not seen a computer like what we think computers are, like, silicon based, electrical, like voltage based or optical
There's
based
a circuit board,
things
that's a computer.
that arise out of organic chemistry, right? Like there's processes in the body that you can think of as computers. There's a little mechanism in the cell membrane that you can think of, or that looks like a motor, like an engine, right?
Yeah, like a human brain, there's electric circuits. Like there's electricity firing in our brains.
Yes.
That's how we process information
Yes.
through our five senses. So you could almost say that humans are machines. They're just organic machines.
Yes.
Or are the machines
not artificial
imitating
ones.
us? Who
Yeah.
came first?
So I definitely think that human intelligence is natural intelligence as
Yes.
opposed to artificial intelligence.
Right. We're imitating the highest form of intelligence that we know of, which is us humans. Yeah.
Mhm.
And AI should be at that level.
Yeah. According to some people, dolphins might be more intelligent, but that's an inner joke.
I mean, we could imitate dolphin intelligence. Actually, dolphins, they do this thing where they send out like sonic waves to gather information. That's beyond the human, on the electromagnetic spectrum. It is beyond our human senses to gather information that way.
Yep.
So this is something that we could potentially put into a computer, is like how dolphins send out these sonic waves.
Mm-hmm.
They're sending out
definitely.
information.
There's plenty of applications of like weird intelligent things that animals do that us humans are not natural capable of. Like sonar is an example, right? Like bats and dolphins using like sound waves to like orient themselves.
And bats are blind, so they need to send out those sound waves.
Yeah. Yes. I don't know if all bats are blind, but yes, definitely this is a big thing. Then you have sharks have super sensitive electromagnetic receptors in the front of their, like, I don't know how to call that in English, like the snout. I don't know if
What is
that's
this
the word.
animal?
Sharks, like most sharks.
Sharks, yeah, they have really cool abilities beyond ours.
And so some animals have the ability to see in wavelengths that we cannot see.
Yes.
Like ultraviolet or infrared.
Infrared, like snakes can see,
Yeah.
I believe, thermal, yeah?
I don't know.
Or
but
infrared. One of those words.
Yeah, so for example, some insects, definitely dogs have a different frequency response in their eyes.
Well, you're the
than
wave
human
guy,
eyes.
so this is actually perfect because I think about these things, but you would be able to really dissect them. I really do like sharks because they can send something out where they're able to feel your heartbeat. So they say that when sharks go for their kill, they actually roll their eyes to the back of their head so that they can just focus on feeling the heartbeat of their prey nearby.
Oh, wow. I did not know
and
this.
that's sending through the
That's cool.
water, the waves.
That's really cool.
Yeah, like imagine like the bat example. Imagine like drones, right? We have machines that fly around and we've given them artificial vision based off of cameras because that's all we know. We see this way, so we made cameras this way. But imagine we gave them what bats have, which is like this sonar waves that allow them to see in a different way.
Yeah. Really cool. And like I think in recent times, big example of this is a James Webb telescope.
Oh.
Where Hubble, like big telescope Hubble, would scan space for radiation in the visible part of the spectrum. The James Webb telescope is scanning the infrared part of the spectrum. And that's enabled it to see things that we haven't been able to see before.
Right. I
Yeah.
wonder what the infrared is revealing But I get your point is that we've only been able to take pictures the way we've always done in cameras, but now they're adding these abilities beyond regular human five senses.
Exactly. Yeah, and like if you go online and you search JWST, James Webb Space Telescope, or JWST, you'll see some images, like shocking images of like faraway galaxies that James Webb has been able to capture that you cannot see, even if you had like infinite magnification power. Like imagine your eyes could zoom in into the galaxies far, far away.
Okay.
Your eyes would still not be able to perceive the things, for lack of a better word, that are out there, because the radiation they emit is in a range of frequencies that a human eye cannot see.
Right. If they have an image of that, we're not going to be able to see that. However, we have data, so we can describe it with numbers.
Yes.
Yeah.
And you can tune a quote-unquote vision algorithm to take the spectrum of frequencies that the human eye would be able to see and like artificially expand it.
Right, transform
and render it as if it was an image that you can see. And there's images that have been captured like this. Fantastic, crazy, weird formations that look like clouds and like many other really interesting things that have been done by this.
Yeah, that's amazing. So machines are helping us to see things that we've never seen before.
Correct. Yeah.
Yeah.
And do things. Yeah.
Yeah, and of course get things done. So I think that was a pretty great discussion on what AI is. You can describe some of your favorite projects that you've worked on or are working on.
So when you said, "Hey, I have this podcast, and would you like to talk?" One of the things that I sent you that I'm really, really into right now is exploring and understanding what are the limits of self-hosted AI. So I've had a home lab at home, so like a bunch of computers that I have arranged to host different things. So I have databases and applications and things like that.
You have your own server center.
Yes, correct.
Okay.
I have, most recently, I got a couple DGX Sparks. So like NVIDIA has this little computer called DGX Spark that is equivalent to like a 5070, like an RTX 5070 graphics card.
Okay.
So it's not really super powerful, but the thing that is different, like really interesting from it, is it comes with 120 gigabytes of unified memory.
Unified memory.
And that means that where you would have needed a cluster of graphics cards or computers that have graphics cards in them so that you could fit a model in them, now you can just load a model into a single computer or into like two in a cluster, which is what I have at home.
So it takes up a lot less physical space, but it's holding the same amount of compute and storage.
Yeah.
Amazing.
It's like a little box like this.
Amazing.
Fantastic things. And so I've been testing a bunch of different models that are open source or open weights. And so I've been doing voice stack, so like voice generation, transcription, image generation, going from images to 3D models or 3D scenes. I have an optical character recognition, so like scanning
classical computer
documents.
vision.
Yeah. And so a combination of really high, like finely tuned document scanning models with an LLM at the end to do corrections.
Yeah, I'm glad you brought up LLMs with this because I feel like it has changed the landscape of NLP dramatically from 2023 on. Like I even describe as traditional NLP and now this modern ChatGPT era of NLP that we're in.
Right.
So you talked about doing some audio transcription.
Yes.
I mean, previously it would have been this huge project. You know, the leader was AWS in 2020. They had the AWS Transcribe.
Yep.
But it was still quite a lot of work, and the Fourier transform is behind this. I think today there are services. I mean, there's competing services. You just click a button, upload your files, and within minutes you have transcriptions.
So yes, and like local AI is not at a point today where you can say that's it. I'm only going to use local AI, and I'm not gonna look at hosted models or frontier models. I don't think we're there yet, but I think it's very important to continue to explore what's possible locally for a few reasons. One, it gives you the ability to be self-sufficient in the face of not being able to access, cloud models.
Yes.
Say there's a disaster, there's no internet. Well, I now have some level of artificial intelligence that I can rely on that is local, that does not need internet connections.
Well, it's tricky because as software engineers, we're used to using open source libraries and just picking up where they left off. So traditionally, we were kind of just copying other people's code, adding on to it, and keep on evolving. But now there's ChatGPT and Claude Code, Codex, all these things out there where they're just doing all of the work for us. But you have this good point of like, you should kind of hold some autonomy. You're holding your own servers, but there's a way people could even just use their laptops and still develop locally.
Yes, correct. And the level of intelligence that these local models have that you can run without an internet connection, for example, is not at the level of, Claude, Opus, or Sonnet, or maybe Sonnet, yes. But it is very much enough for a lot of the things that I do. So, for example, this local cluster that is running, I think right now I'm running DeepSeek V4 Flash, like the latest version.
Okay.
It is enough to run a background research agent that I built, that I'm able to give a bunch of topics that I want to research and just, goes out and does research, but then also wakes up on a schedule and goes and figures out on the internet, like doing research, hey, what's new around this topic? And produces like Delta reports.
And this is all being done on your computers, your little service.
This is being done on my computers locally with 0 token payments.
That's pretty impressive.
And like, let's say even it's not enough for the things that I do daily, because I'm a software engineer, I'm building applications. I don't think that I could rely on it for the things that I rely on Opus or GPT 5.6. But what it does is it gives me back some of that budget.
That's what I was just thinking.
Of those subscriptions that I have that are really powerful. Well, now I'm not using some of that budget for things that I can have a smaller model.
And you're a one-man shop. You're an entrepreneur, but you're also writing your own code. Imagine other companies that they have to hire a software engineer, and that software engineer who used to get paid 6 figures to take months to write code, now they sit with Claude Code. It takes them a couple of minutes, and then they're chilling. They're still getting paid the same amount. This is like a gripe I've heard from CEOs lately. It's like, why are they still getting paid the same amount when they're doing a lot less work? With your system, if people could just self-host, they could cut down at least the token cost. Maybe they could figure out other ways to cut their budget, but the tokens eat up quite a lot, especially if people don't know how to use the proper systems, because there are quite a lot of models, like you said, Opus and Fable and all these things. I guess one model is like you need it to get a big task done, but then maybe if you have a smaller task, you should shift down. But like in the past, in cloud computing, because I came from a background of cloud consulting, we would go right into GCP, Microsoft Azure, or AWS, and we would select what machines you need, in what location, what region of the U.S., in Michigan, East, West, whatever made the most sense for your budget. And even if you had some sort of software that like ideally you want a cron job that's a scheduled job that goes once a day or once a week, but sometimes it's just constant. In that case, you would just scale up and down so Amazon doesn't overcharge you. Today, people are using Claude Code, and they don't care. They're like, you just choose my compute power.
Yeah. So Amazon has this thing called the 12-factor apps, which is kind of a guidance on how to do good cloud architecture. Really well cited. In practice, you should really care about total cost of ownership. Is the thing that I've landed on after the years.
Total ownership.
Total cost of ownership, right? So you have a customer problem that you're trying to fix or provide a solution for, and there's always going to be multiple ways in which you can approach that problem. There's going to be variability in the volume of needs that you have over time. And yes, it is tempting to over-provision so that you don't have to worry about it. Some people might under-provision and then like scale up on demand.
Well, especially for seasonal businesses, like if you're selling bicycles in the summer, they're not going to sell in the winter, and you have some online platform. winter's going to be dead. Why are you paying the same amount as you do in
Right,
summer?
and that happens at many different scales because like you're talking about seasons in the year,
Mhm.
and yes, there's a distinct uh, gap between the traffic that an e-commerce gets around Black Friday, and the traffic you get the rest of the year.
Sites go down. People
Right.
can't make their purchases.
But then you can also look at it in other scales of time, right? So there's a distinct traffic pattern in business applications that are mostly used during the week.
Okay.
So you might have a lot of traffic Monday through Wednesday, and then not a lot of traffic on Saturday and Sunday.
Yes, and if you know that in advance through some sort of data analysis,
Yeah.
you can plan your compute around it.
And
save
you can
money.
plan your computer around it.
Yeah.
And then even during the day, especially if it's like business-to-business apps, right, and you're serving a specific geography, well, you might see a traffic pattern that starts to go up, I don't know, 8 a.m., 9 a.m. Eastern time, and then finally like goes back to like a base, like 9 p.m., which is like, I don't know, 5, 6 p.m. Pacific time, right?
But when people are using Claude Code and Codex, I don't think they have the ability to get in there and tune their compute power.
No, but in the same way that you can think of, I don't need the same amount of compute in a business like B2B application over time. You can think of, I don't need the same amount of compute or the same amount of intelligence over different types of tasks. So it's a little bit of a lateral move, right? I know I'm comparing complexity of a task with time, which that makes no sense. But if you think of, domain to or like source domain to target domain, and you think of like the work that you're doing as a function, right? You're going from traffic over time.
Okay, this function has inputs. Let's see.
So you're going from, if you go from traffic over time, right? And the function is compute.
Okay, traffic to your website of customers.
Yes.
Right, we got people coming in Monday to Friday, but on the weekends, not so much.
Yeah, and not like in the middle of the night, but like super high at, I don't know, 11 a.m., right? You can, if you abstract away what it is that time is, and you instead think of the complexity of the task on a line where you have tasks that have low complexity and tasks that have high complexity, right? Of the things that you do day to day.
The complexity of developing the code behind your tool.
Yeah, and I also understand that that's, that's like a very abstract notion.
Yeah.
But you don't need the same amount of hard thinking to write a commit message.
Right.
Than you do to build a time series analysis pipeline. Right.
And it gets even more complicated. Then you have some video computer vision project. There's so much complexity on a range. I mean, I tried Claude Code. I just typed in LS. I want to list out my local files, and it ran for 2 minutes.
What?
Yeah, because it's on some high model, right? So I think your point is like selecting a specific model.
Oh, because it did a lot of thinking. Yeah.
It doesn't need to do that.
I mean, long story short, choose the right tool for the job.
Choose the right tool for the job, which in this case is the different models offered by Claude Code and all of them.
You have 2 dimensions there that I would think of. You have the model that you're choosing, and then how big of a thinking budget you give it. So Claude calls this effort. If you're using open code calls this variance for the model.
Okay.
I don't know if Codex, I don't know how Codex calls it.
Yeah.
But same concept, right? You should not, or it's not, how do I say this? It is not the best use of your token budget or your subscription allowance when you're using one of these hosted models to just throw the biggest, baddest model at every task, right?
You're right. We could be smarter than that.
And what that means is then if you had models that are self-hosted and there's a level of intelligence needed for some of the tasks that your self-hosted model is more than capable of of giving you,
Yeah.
then you can be intelligent in what model you use for which task,
Yeah.
or even combine big, hard thinking models with your local model that is maybe less capable.
There's definitely a lot of
seamlessly.
strategies to optimize the budget for developing software.
Yeah.
And we just discussed how doing it through the vibe coding world of Claude Code and Codex, you can choose different models and different effort levels. But once the code is developed, there's still that other side of it's still being hosted
Mm-hmm.
in the cloud somewhere, and we don't know how that operates, if it needs to scale up and down. I think people never even see that. They just don't care how their code is being run.
And I'll give you another one. Like some applications, after they are built, might still incorporate a language model as part of the feature set that they provide the user. So think I have a deep research harness that I built with an agent that's running on my server. I am able to give it new topics, and I can set a schedule for the agent to go back and re-research or figure out what's new
Okay,
and
keep
produce
working in the background constantly.
So there's something that's gonna wake up an agent,
Yeah.
and it's gonna have that agent do some searches, read the context,
Wow.
and write a report. That agent, up until I got my self-hosted models, was running on Claude. I think then I made it run on Codex, but now it's just running on self-hosted models.
Okay,
And I
yeah,
am
you took your
paying
money
$0
back.
for tokens
Yes,
for
take
that.
your money back from Anthropic. They're taking everything from you, running in your sleep.
Okay. Yeah. I don't have anything against Anthropic being a business.
Yeah, no, but
I
now
just
you
don't like
have-
wasting money if I can avoid it.
No, that's smart. I mean, a lot more people should try to be self-sufficient like that. It's just challenging, like not many people can just host a bunch of computers in their living room and then have it's not even the knowledge, because the knowledge is out there. It's more so like the confidence to be like, yes, I can just self-host everything, not have to pay for tokens anymore, save that little bit of budget. I think your background, going from electrical engineering to software engineer to entrepreneur, this has given you all the confidence you need to have your own server center.
Yeah, for sure. Definitely not. Definitely a higher learning curve when you want to start self-hosting your own applications. It's a lot easier than it used to be, though, right? I was able to buy this computer, set it up, connect it to my network, and ask my agent to install the model and start serving it.
Yeah, it's
And then
so
if things go
easy.
wrong, I can go in, right? So with this, I'm trying to say, you used to need to be like a hosting architect, or hosting architect is not the right word. You used to need a lot more knowledge and experience in order to self-host something in any reliable way. It's a lot more accessible these days even for people who are not engineers. Like there's one-click solutions.
Okay.
Yeah.
Let's say I want to start doing like Bitcoin mining. I want to set up in my living room like 5 machines and have them run I make some sort of AI agent that's like awesome at the transactions, the hashing functions.
Okay.
But I want to self-host it.
Interesting. Why Bitcoin mining?
I don't know.
What did that come up?
I know a bunch of Bitcoiners in Chicago. I go to the Bitcoin Collective of Chicago, and they just have little machines all over the place.
So Bitcoin is an interesting thing. Bitcoin at this point is such a compute requiring activity that I definitely would not have AI agents or any regular computers mining Bitcoin.
What?
Yeah. There's specialized computers for it. There's been for a while where it just doesn't even make sense.
It's just too complex?
There's specialized hardware built for the algorithm in Bitcoin block
Okay.
mining, where just the regular computers that you can buy and set up at home just don't stand a chance.
No way. I wonder if that's because Bitcoin is the most popular one, so they probably have the most transactions and the most developers who've figured out the best hashing functions.
So this happens. Bitcoin's hashing function is SHA-256.
SHA-256, yes.
And there's machines purpose-built to run SHA-256. There's hardware that is bespoke for this, like ASICs, application-specific and integrated circuits, right? And so, yeah, your GPU stands no chance against an ASIC miner.
Oh, yeah. Okay, because my last guest on the podcast was also part of the Chicago Bitcoin Collective, and they have their own machines. It's called BitAxe, where they are running the SHA-256 thing, and I think they described it just like you.
Like an ASIC, yeah.
Yeah.
Like a special hardware that's designed for that purpose and optimized for that purpose.
Yeah.
For throughput, right?
Like if anybody can operate in the space, it would be them. Me, I don't really know as much about crypto, but like hypothetically, if I wanted to hold my own servers in my living room, maybe there's another use case for it. But like that's the first thing I think of because that's what is more common for non-developer people who just have machines at home. Either that or video gaming. But in this new world, I guess you're using your own server center for whatever you want.
Yeah. There's a bunch of other stuff that's running in there, not just the AI models. Like I've got databases, I've got application servers, like file management.
Yeah, because like if we talked about this 5-10 years ago, if people have machines at home, they're either Bitcoin mining or they are like a video game fanatic.
The average people, yes. There's always been the nerds like me that had all the other things. Yeah, like your
they
private
call me queen
cloud.
of the nerds.
Yeah.
Even my best friend in Chicago, she's like built computers and they have their own server of, I don't know, they do Minecraft, right?
Oh yeah.
These are all the nerds. This is what they do.
Like
they
a
just
game
have
server.
computers.
Yeah.
We just always have extra computers.
I have so many.
We'll see what the future holds.
I have lost count. I have so many.
Computer collector.
Yeah, I guess. Yeah.
Okay. Well, you can tell us about any future impact that you hope to have while you're pioneering the space with AI.
Yeah, so there's a few things that are occupying my attention these days, right? There's Hello Miami, which is a technical community that meets twice per week in Miami. We meet Tuesdays and Thursdays.
Yes, hack night.
Yes.
Let's go.
And so it's a fantastic place. It's helped me learn a lot about areas of technology that I didn't have a chance to go into
a lot of
before.
talented people show up.
Yes. I've met fantastic people. The developer Bruno that built the agent that I'm using, I met him at a hack night and he brought his project, showed us, and then a bunch of us are starting using it. So definitely interesting. And then there's a lot of other communities that host here in Miami, specifically at the lab with the doc. Fantastic. And so that activity or that growth in activity is like very interesting to me. I've lived in Miami for 10 years and it didn't used to be this vibrant around technology.
I agree, because I had lived here. I moved out a year ago and I was here for 3 years. I would go to 1 or 2 AI hackathons per year. Now I'm going to 3 to 5 events per day.
Yeah, wow.
Yeah,
okay,
the space has changed quite a bit.
Yeah. And so, Hack Night, Hello Miami we're doing a little bit of a push on our end to contribute to that. And the vision is for Miami to become a top-notch technology hub. It's never gonna, I don't think that it's ever gonna be what Austin is or New York is or San Francisco is, in the sense that Miami is very unique.
Oh, yeah.
It's this is fun meme of Miami is in a state of its own thing.
Yeah. We're not in Florida. We're in Miami-Dade County.
Yeah. And so Miami is very unique in terms of the way we approach life. It's a very Florida type of thing.
Yeah, you say sun and fun.
Yeah, exactly.
Yes.
But within that, there's a lot of fantastic people that are working in technology or trying to get into technology. And so I like that we're working to give them that space, right? So that's Hello Miami. And then there's the local AI We do office hours at the dock every other week to help startup founders and people
Oh.
trying to get into building a business or building an app.
Well, you're hosting a lot of events per week then.
We host two hack nights per week, and then we host 3 different office hours every other week,
Amazing.
on and off. I host technology and go to market. Ali hosts. Ali is the founder of Hello Miami, and she's
Yeah,
also
I
a co-host
know
at Hack
Ali.
Night. Yeah.
We met at a hackathon like 2 or 3 years ago.
Yeah,
It was
she mentioned,
over
yeah.
here, and like most people were doing software,
Mhm.
but I found Ali doing hardware and
Correct.
showing a video jumping out of a plane for research purposes.
Yes. So Ali's a creative technologist, and
Yeah.
she works in embedded devices, LED installations, 3D modeling, and so she hosts office hours helping people work through hardware projects.
Yeah, hardware is so rare to see. So
Mm-hmm.
now when I see these people developing hardware of the future, not just like recreating some circuit boards, like they're actually innovating in the space, I can just tell they're very rare individuals.
Yeah, and like she's got these projects that like the one you mentioned, right? Like super crazy. Like drop um, a measuring board, like it's a board full of sensors from like a balloon, and then like measure. I can't remember what it was. But, like do some measurements on its way down.
Okay.
And then she's built this 3D like LED glasses that go on top of her prescription that have
What?
LED and like a microcontroller that does like different animations. Like she uses to go
Like
to
some AR stuff.
so not AI as in
Like AR.
yeah, not even that. It's just a frame that has LEDs all over, and she
Oh.
like it lets her
It looks
play.
cool.
Yeah. It's like a personal style piece. I
Yeah,
think.
give a little flavor.
And then Fernando, whose background is in design and is a front end engineer, then he's been helping people with design and user experience and front end development. And you can see us get into these things at Hack Night, but then we also have created this space for
Yeah.
people to come.
I could tell you really care about the community that you're fostering here in Miami.
Yeah,
And
for sure.
I'll tell you, I really like the vibe at Hack Night.
Oh, I appreciate that. Yeah.
You're doing great.
Hack Night, Ali and Jose, who is not in Miami anymore, he moved to San Francisco. They started it. I started going, I think, on number 4. This was 2.5 years ago. And then I moved away and came back to like downtown Miami, and super surprised that they were still doing it. They were still doing Hack Night. And at that time, it was Ali was hosting by herself. And I was like, hey, I see you're hosting by yourself. Jose moved away. Do you want some help? And she said, yeah, I would love some help. And so I joined. It's about a year and a half ago, I think. And for me, at that point, it was a no-brainer because I wanted something like Hack Night to exist.
Yeah, we needed it here.
Yeah, it's designed to be sort of a third place for people who are in technology, but that want a place to meet other people that is in a place that is not work, that is
Right.
not home, right? So
Yeah.
you can think of it as, like a hobby for nerds.
I love it.
But it also serves as a place for startup founders and people trying to get into tech, or people trying to explore different technologies, to
Yeah.
meet other people and learn from them.
Like the collaboration energy in that
Yeah.
room is unmatched.
And so the format is that. It's around meet other people who are doing technical things, learn from them, or if you have a project and you want to get feedback, then take the stage and give a 5-10 minute demo of your project or the latest things that you've made or your latest project, and get feedback and maybe make adjustments or
Yeah.
get people excited about
I
it.
know that the room is mostly like true software devs, but I'm wondering how many vibe coders you come across.
Increasingly a lot. We've been getting many people who show up saying, I have no idea what this is. I know I have Claude, and I have something that I want to do, or I have GPT or I have Codex, and I have something that I want to
Well,
do.
they came to the right room.
Yes, yes. And so for people who are trying to start building something and don't have a background in like software development or engineering, like our doors are wide open.
This is a great point about people developing without having a software background, right? Because you have to be able to architect the solution, right? You have to know what the end goal is. You're starting from nothing. You have to reach the end, like, say, a huge computer vision problem.
Yeah.
How are you going to know that they will put boundary boxes, or that you could either train an algorithm or find a pre-trained algorithm? And where are those best pre-trained algorithms for computer vision? Like, what tools do you need to know? So as software engineers, we might be able to say that like our code writing is not as in high demand as it used to be because anybody can vibe code now. However, we still architect solutions.
Yeah. The advice that I try to give vibe coders is you have a magnificent tool right now in AI. Use it to amplify yourself.
Okay.
Right? So you might find people who are trying to get the AI to do the thing for them because they don't want to. They don't want to. They don't want to do the work to gain the understanding, and for the most part, you can get some good results that way. Especially if it's like personal software, you're building something for yourself. There's plenty of value to be achieved that way.
Yeah.
My advice when people need to go beyond that is invest in yourself. Use AI as a way to expand your comfort rooms, your comfort area.
Know what you're building while Claude is doing it.
Yeah.
Yeah.
And like that can be intimidating.
Well, I've watched quite a few vibe coders, and they really just say, yeah, I don't know how to do that. You just do it. Versus like, I'm sitting there and I'm reading the error messages. Why is it saying that? It's telling me, like, don't put your API keys here, and then someone else is like, it's okay, let's just keep moving forward. Or there's some block, right, and it's telling you to set things up. People are just like, I don't want to learn how to set that thing up. You just do it, Claude.
I mean, there's value in that, insofar that it enables some people who historically were not able or didn't have the confidence to go and put things together. To just go and try things, right? So not knocking anybody down.
Yeah, but just go try things.
Just more power to you. Go try things. If the things that you're trying to build then become something serious or something valuable, something that you would like to exist for a long time, then it's probably a good idea that you use the AI to gain the understanding.
Right. Yeah. Just know what you're building, Yeah. Go out there, try things, break things, fix them. But know what you're doing for sure.
Yeah, and so I use AI to that in that direction a lot. Anytime, like in addition to building my own things, I like to find really cool, interesting projects on GitHub.
Oh yeah.
And so for example, I might clone a repo and then use Claude or Codex to look at it in ways that are more amenable to me. So I'm a very visual learner, for example. Okay. And one of the things that I have started doing is I tell Claude or Codex, I switch between them, to, hey, take a look at this repo and understand what it's doing and produce a few things for me. One is a map of all the concepts in it, like entities, right?
Okay.
And show me how the pieces of data that this application handles relate to each other. It's like, just give me a diagram. There's a user over here, and there's, there's a project over here, and a project have files. And then a file always belongs to a project. A project can have many files. Users can have many projects, something like that, right? In software engineering, you might call that an entity relationship diagram.
Okay.
So like a map of concepts and the relationships.
The flow of the project.
Yeah. And then one other thing that I often ask my agents to do is go and figure out what are all the entry points
Yeah.
of behavior to the application. So, like for example, there's an API or there's some UI, and then the user can do certain actions in that UI. Well, that triggers a set of like a path of execution. Go and give me sequence diagrams for all of these use cases
Right.
in the project.
Like how
And
a
I use
user,
that, yeah.
the
and-
user experience rather than like a knowledge graph of a database. And
correct.
that's like the database is fixed. You can make a knowledge graph of everything, but what you're talking about is like some app that a user is using. How do they go through? They land on your page, they click a button. Everything behind that.
Yeah. What happens?
Yeah.
Right. And what are the rules? Like, what's the validation in here? What are the things that have to be true for this use case to be possible? Right. And so I ask the LLMs to give me diagrams and charts and like sequence diagrams.
This is what
And that
you
helps a
mean.
lot in understanding how something works that I didn't build myself.
I see. Yeah, because you talk a lot about these ontologies and
Yep.
knowledge management. So I guess this is that. You go find a project that you enjoy and then outline a diagram of their flow, and then maybe you can recreate something different.
Yeah, or maybe I really like what they're doing and I want to extend it in a specific direction and I build my own version of it.
Yes.
Or I really like the people who are behind the project and I want to help them advance that project, and they might have some issues on GitHub that are marked as this is like a first thing to tackle to contribute here, and I might help and contribute some fixes.
This is like the double-edged sword of software development in general. Is open source is great, right? We get to pick up where someone left off, so we don't do the same work twice and expand on it. That's beautiful. But at the same time, then we are using someone's work for free. Some people are using that to make money in their business without compensating the developer of that open source code on GitHub.
Yeah. So there's if you are like if you come across a project that you like, and that project has a specific license on it, then depending on what the license is, there's some rules of engagement there. MIT and Apache are two software licenses that are really popular, and they grant the ability to take that software and build something on top of it or modify it. And MIT is the most, the least restrictive one of the two.
Okay.
It still requires that you credit the original author, right? So totally fair game. If the author of a project or a library decided to open source it under the MIT license, it's okay. They made it that way.
But if I just commit stuff to some GitHub project and someone goes and uses my code base, I'm not covered by that because I didn't register with MIT.
That's a good point. Typically, when you see projects that are really popular that get a lot of contributions back, or not typically, but often you'll see that they adopt a process for contributing back.
Yeah, once they get popular, then they start to worry about this.
Yeah, and
Yeah.
so for example, I can't remember which one. It's common that you'll see the author of a project say, "Hey, read this document if you want to contribute," right? And what I understand or the way that I approach it is if there is no specific license called out in a contribution instructions file, then I assume that if I contribute back to that project, I'm licensing my work under the same license as the project.
Okay.
Like if it's MIT and I send a pull request that fixes something or adds a feature, well, I assume that it's going to be, I'm giving back an MIT license because it's going to be made into that project. If it gets merged, it's going to be made into that project, and then it becomes licensed as MIT.
Even though like it was licensed, then you grabbed that project, embellished it, and made your own.
Yeah.
You still think it's licensed by MIT?
No. So let's say if I fork a repo, clone it to my machine, make some changes, and they happen to be useful for the original project or the original author.
Okay.
And if I send a pull request back, right? Some projects you'll see that have like clarified that if you send a pull request back, you need to sign this like agreement, and you give them a license back for your modifications.
Yeah, and
If
they have
that
to
doesn't
accept it.
exist, then I'm just gonna assume you're an MIT project. I made some changes. You might want them back because they might be useful to you. Here's my changes back. Here's my way to contribute back to the project. Or,
Yeah, if
MIT
they're
as well.
accepting it to be merged,
Yeah.
then they're gonna cover it with their license. That makes sense.
Yes.
Yeah, yeah.
Now, if I took a project that is MIT, and forked it and built my own thing on top of that, then the license allows you to do that for even for commercial purposes, and so does Apache, by the way.
Okay.
Yeah, this is part of the license. Some other licenses don't allow you to do that, or require that you have like that. There's additional things, like for example, GPL, like GNU Public License, requires that any modification or any software that you built that is based on something that is licensed under the GPL must also be open sourced under the GPL.
Okay, that's a lot of complicated licensing stuff.
Project A has licensed GPL. I take that, build Project B. Project B must also have GPL license.
Oh, because you're using their stuff. They want it to
because
stay
because the
licensed.
GPL license has that
Or
language
they'll
in
sue
it.
you.
Yeah.
Yeah.
They would have the right to sue you.
Yeah, they'd have the right to sue you. Okay.
But Project A built with MIT, I fork it, built something else out of that. I can use whatever license I would want. The requirement of the MIT license is that you retain the original copyright and you credit the original author.
Okay.
And Apache has a few other requirements, but overall, same spirit,
Yeah, I
right?
can
This
tell
is
you've
open
looked
source,
into
you can
this.
take it. Yeah.
Yeah, you're deep in this.
Yeah. So I think it's beautiful that people build something that make it available for other people to use. The license being the one that they chose. If you go to my GitHub, most of the stuff that you'll find there that I have forked, then some of them I haven't done anything with. Some of them I have contributed back. Some of them I have released as MIT anyway, and some things I built from scratch that are MIT licensed. And I like to choose that license specifically because most of the things that I make public are designed to be available for people to build something on top of if they want.
Yeah, so it's better that you take the standard best of that time, build on it. That becomes the next best, and it's the best for everyone to use.
Yep.
I wonder if there's a term to describe that. Like I know when it comes to natural language processing, we always did something called transfer learning. So I wonder if there's a broader term for all of software where it's like transferring and building upon.
Oh, that's a cool way to look at or think of it. Yeah. I certainly do that a lot. GitHub has this thing called this tab called Explore, where you can go in and you can see what repos are popular, and you can filter by language, by technology, and stuff like that. I'm there all the time.
Yeah.
And I'm also looking at what people are talking about on Twitter. This is how I found that you can actually host DeepSeek, like in your own computer, like we were talking at the beginning of the conversation, right? Because people were talking about it on X. And so like I do this very often, maybe every couple days or so, where I go in, I check what's popular, what have people been posting about, what projects are actively being maintained, and I take some time to like find the ones that are more interesting to me at that point, and then just go and read their code.
Yeah, it sounds like it's getting a lot more complex these days because there's just so much software out there to choose from. It used to be like, every time you import a library, you are using somebody else's code that probably lives on GitHub. But, it used to be standard imports, kind of the same ones over and over again. Now we have, like, the whole world has the ability to write code.
Yeah.
So there's so many competitors out there. That's why you look on X and you look at all these different sources of what's the most popular, and then you have to do research. It's probably, like, a huge vetting process for which tool is actually the best for the job.
Yeah, there's tooling around it, you can look at who this person is, what have they done before. You can also look at tooling that GitHub itself has that will scan that code. We'll check it against like public list of vulnerabilities. A big factor in deciding this project is interesting and I want to use it or build it or integrate it into my app. We'll go through what technology is it using, and is it the same technology that I'm using? Like, for example, is there a library that is built in the same framework that I use for my app? Right. So
Yeah.
let's say, hey, similar technology. It's a different. It's a feature that I don't have, but it's supported by the same libraries under the hood. Oh, great! I might feel more inclined to look at that library and try to incorporate it or use it or see where it's useful than something that's a different technology, right? So there's a lot of tooling building software applications these days, even if it's for yourself with an AI agent, or on the other extreme of that, for like a company. It's a lot simpler than it used to be before.
Okay.
Yep.
Well, it sounds like you do your research and always find the best software and just build upon that. So it's good to see that software engineering is still alive and kicking despite all the vibe coding, all these options out here. So it's actually in a place where I feel that we've democratized. I would say, I used to say 10 years ago, democratize data science. I wanted everyone to be able to have data science.
Yeah.
But it's gone so much farther than that. We've democratized AI agents. We've democratized all of software engineering because you can really do anything with Claude Code. You can do app development. You can outline some infrastructure. People are doing things outside of software, so it's really democratized everything. Democratized.
It really has. I definitely think AI is a transformative technology. We are just getting started understanding the things that it enables us to do. And like, I'm an early adopter. I'm self-hosting some models at home. I definitely think that the future is going to be even more ease of access and cost reduction so that more broadly people can use it.
Yes, I love talking about the future. Like, tell me what you think the future holds.
I think that I definitely see a future where local AI is part of people's everyday. Whether that means AI that runs on your phone, AI that runs on your laptop, AI that runs on a dedicated, piece of hardware that you have. It's just such a transformative technology. I also think that in our future, it's going to become a lot more important that that AI switches from just brute force, quote unquote,
You think that the
direction.
state of AI is brute force right now?
It certainly is. Yes. The way that you train LLMs today, and this might be controversial.
Yeah.
Don't
Let's
at
see.
me if you want. The way that the world trains LLMs right today, is, or the way that the LLMs are scaled today, is following this idea that there are capabilities that get unlocked or that manifest themselves or that emerge when you have much, much bigger networks and much bigger data sets than you would have initially thought that was needed to approximate a function.
Yeah, like if someone told me, like, you really got to get the best answer and you got to do it in 5 minutes, as a data scientist who can train LLMs, I would just try all of them at once. I wouldn't care about the compute costs. I would just try as many neural network algorithms as possible, feed them different versions of the data set, maybe filter out outliers, whatever different samples you might try, filter different data sets, keep the same data set, but try different algorithms. I mean, this is traditional machine learning too. I used to have to sit there and do thousands of algorithms for one problem using weights and biases to find the best one given some metric. So I imagine if someone like me is hired to create those LLMs, they would do the same thing, especially if people are paying for these services to get the answer now. So yeah, just try them all. We don't care how much compute it costs.
Yeah, so like counterintuitively, you imagine you have done this process and you've decided that a convolutional neural network is the architecture that you want, right? And then you train a model. It's a CNN, right? And then you train the first version of it, and you don't get the results that you were expecting. And then you try making it deeper or wider, and then you get a little better result, but then you start getting diminishing returns.
But you need time for that iterative process. If you're
Yeah.
using Claude Code, I want the answer now. They're running for 5 minutes. Maybe they're iterating a little bit, but I would iterate over months, you know?
So this I don't have the facts straight. So I'm gonna paraphrase
We
here.
need a fact checker.
The idea here being that at some point during the transformer research, on the jump from GPT-2 to GPT-3, for some reason that I don't understand or don't fully remember right now, even though I've heard this mentioned multiple times, somebody decided to scale the network far beyond what they thought. Counterintuitively,
Like adding more layers.
yeah, because the gains from loss function from adding layers and adding making layers wider had started yielding diminishing returns.
But still returns nonetheless.
But it turns out that past a certain size, the network started improving a lot more.
See, how would they have known that unless they started trying to expand it and just keep going?
I don't know.
Yeah, I gotta
Somebody
experiment.
did, and somebody figured that out.
Some data scientist somewhere was like, let's just keep trying things.
And so when you take the scaling or a plot, like a log plot of models, and you plot performance versus the size of the model. Performance.
Oh,
so sorry.
performance.
Yes,
so you'd
performance
have to pick up performance metric.
versus the size of the model, then it still is the case that taking the same model architecture
Yeah, it's like the epochs.
and scaling it, like making the model bigger, gives you better results.
Yeah.
So
But when we run the experiments, they'd have to say, okay, try layers from 1 to 100. But some other data scientist was like, try layers 1 through 1,000,000.
something like that.
Yeah.
Yes. And so that, to this day, has not been refuted as a good way to get more performance, better performance out of
Imagine
models.
their computers must have been running overnight for days.
I guess,
Yeah,
yeah.
because mine used to run. I'd have to keep it for 24 hours.
So, yeah, so training runs these days are months long.
Wow.
Yeah.
24/7.
Yep.
Yeah, because if you got one neural network that's 1,000 layers deep, and now you're talking about millions of neural networks that each could be millions of layers deep with different data sets. That's just so much compute.
Lots of compute. Yes.
Lots of compute. Our favorite.
Yeah. And so back to what I was saying, right? So there's a big component of the way that LLMs are being trained today, which is centered around make the network bigger.
Yeah, brute force it.
There's also fantastic algorithmic improvements. Like if you look at some of the ones that we can look at, right, that are open weights and open source and open research, there's fantastic algorithmic improvements from Mistral, which is a French company, a bunch of Chinese labs. Poolside AI had this company launched Laguna. Laguna's Mol 2.1. It was the model that was running on my home lab before I switched to DeepSeek. And then they also incorporate a bunch of interesting algorithmic improvements to the models, like speculative decoding and things like that. So it's not all of it is not brute forcing. There's a lot of intelligent design going into the ways that LLMs are being built. But the transformer architecture and the way that transformers work is decidedly not symbolic AI or like
Symbolic?
expert systems, like rules based, concepts based. It's like
Okay.
before we went or humanity. I was not a part of
Humanity,
it.
not
Yeah.
the machine.
Before LLMs became the way that you train language models, right? Traditional NLP or traditional models or traditional AI had versions of it or forms of building AI systems that was rules based
Rules
or
based.
constraints based. So, for example, I'll give you an example that is probably easier to think of without getting into the details. But like, if you look at gaming, like game systems that have AI participants in them, right? So especially like legacy systems. When I was in college, I used to play a lot of Dota and Warcraft 3, and you would have AI or computers that would compete against you in the game.
Okay.
Those were not language models. Those were not like neural networks.
Yeah.
Those were rules-based
They're
systems.
little agents or entities.
Yes.
Yes.
And so my like all of this, like long story short, all of this I'm saying is to get back at the point that I see a resurgence of the desire to merge the raw capability for reasoning that we get from LLMs with rules-based deterministic systems and combine them in creative ways that help build solutions that have the best of both worlds.
So what you're describing, I would align that with reinforcement learning, if you've heard of that.
Yeah.
So in machine learning, there's of course supervised, unsupervised, and reinforcement learning. The reinforcement learning one is basically, to distill it down, if you can go left or go right, I will either reward you or punish you for doing that. And you can create like a metric system, a number system where it's +1, -1. So the agent starts to learn what behavior will reward it. And it will start to create rules for itself that we wouldn't even know to give it.
And yes, and this would be during training, right? You're hill climbing on a metric, and you're deciding what to which direction to nudge weights and biases,
Yeah,
right?
like we wouldn't tell it; it would just learn.
Right. Now, let's say you trained a model, and you're using, let's say you're taking DeepSeek. It was already trained, and you're hosting it yourself, and now you're running inference on it, right? There's been a bunch of, I keep saying a bunch. We might need to cut that part.
Do you?
So there's been significant research over the last couple of years about the effects that you get when you ground LLMs on structured information. So there's research that uses LLMs to produce ontologies as a way to provide structure to a knowledge graph.
Yeah, structured versus unstructured.
Yeah, there's research around using LLMs and graph retrieval to ground answer generation, for example. So which are things, and you can see that, like, I get excited about these things, but also like there's a lot that I need to research here. Yeah. But it's an interesting direction for the future for me.
Yeah, for sure, especially with this graph retrieval. Graphs are so complex to traverse. In the world of mathematics, the most unsolved problems that are out there are in graph theory. To traverse a graph, and you're saying you're doing it for search purposes.
Yes, so there's applications of graph retrieval for search. There's also applications of it for code generation and building systems. There's also applications for deciding trajectories for an agent that is doing human-like tasks. So definitely seeing a lot of research around systems that not only are weights and biases, but systems that are also operating over symbols or like labeled entities.
Yeah, I like symbols, like everything in mathematics can be distilled back to just counting, and you can symbolize this, especially with graph theory, just circles and lines that connect ideas together.
Right. So that's another great way to look at it, right? So if you take calculus, for example, and you
My
do
favorite.
and you do differentiation on a function, right?
Okay.
Depending on what function you're working with, like mathematical function you're working with, right? You might be able to get an expression for the derivative or the integral, right,
Sure.
of a function. And then there are other situations in which an expression is not available or it's too complex to compute. And then you do numerical methods. So you have this duality in techniques in math and in engineering where if you can get clean symbolic expressions, then that gives you a lot of power in analysis. Sometimes that is not possible. But neither of the two approaches, like symbolic math and numerical math, are enough for 100% of what engineering and math needs in the real world or physics, right? And so a combination of them is really useful.
Sprinkle in a little creativity.
And so I see an analogy between that you see in math and engineering and physics showing up in the way that we use LLMs.
Oh.
Because if you just take an LLM, then yes, it's fantastic. But if you combine an LLM with structured data retrieval, you can use that structured data to ground what the agent will produce, or to evaluate whether what the agent produced is right or correct, or introduces discrepancies with a body of work.
Yeah, but you need some expertise to know what to feed it.
Yeah, and so many applications of that in training. So you can use a semantic reasoner or a system that deterministically reasons through knowledge as a judge in the output or in the training process of a model.
The agent is a judge.
In this case, it would not be an agent as a judge. It would be similar to agent as a judge or LLM as a judge, but it would be deterministic reasoning system as a judge. And you can use that to decide whether the output of the iteration or the epoch is positive or not.
Yeah, I guess that's kind of like hedging here so that you can not just only rely on agents, but throw in a little symbolic math and these other strategies that you say so that it can kind of like double check that agent.
Yes, that being the idea.
Yeah.
So if you, let's say let's take a model and you're hill climbing, you're trying to minimize an error function, which is, at the core, the simplest way that I can, explain or talk about the training process, right? Mm-hmm. And I'm not an expert in training, so definitely will make it minimize an error function, right? Now, that minimization of an error function is, of course, a numerical method. You're taking the output of the network and you're evaluating it against what you expected, what the right answer is, what the correct answer is at the output, what the output was expected. And then you find an error and you determine in which direction, positive or negative, that error is. And then you go back and you back propagate that error.
Yeah.
Right.
This is like in the case where you do know what the right answer is, and then you can check the error between predicted versus actual.
Correct. Now, at a higher level, you take a network that produces text, an LLM, right? And then that LLM or that output can be interpreted at a higher level of information.
That's such a complex task, though, because if it's generating a response, I mean, people are like, there's no wrong answer here. It's kind of like subjective, but at the same time, it has to be on topic. Mm-hmm. Mm-hmm. So it'll be challenging to find a good metric.
Imagine you take an LLM, it produces some text response, and then that text response has an interpretation in a text format, like a JSON object that does some tool calling. And you want to give you an example, you wanna fine tune a model to prefer calling a certain tool versus another one, or you want to fine tune a model to prefer calling tools instead of just producing a response. Right? If you have a deterministic way to evaluate whether the tool code that was produced is correct or not, then now you have a higher order signal to feedback the training process, the fine tuning process.
By using multiple tools.
Either by using multiple tools or by making sure that the model is picking the right tool from a tool set or the right parameters to pass to a tool.
Yeah, and then you were also talking about measuring the error as well.
Yeah, and I guess in this case, care should be taken to create a gradient. The base version of it that I can think of as a binary decision. Did it produce the right tool or not? But if it, let's say, if it produced correct JSON, but the data that's inside that JSON of the tool call is not correct, then you can assign a different score, right?
Yeah, so like I'm imagining you talk to ChatGPT, it gives you a response. All the words in that response, we're going to call it a document. Now we want to measure how well did that thing respond.
Yes.
Yes, okay.
That's one way to think of it. Yes,
Perfect.
yes.
So the metrics that I would use here, one is called coherence.
Yeah.
So you can measure how well the words on the page relate back to one major topic or a few major topics that they were meant to respond to. So the coherence of the topics in there, and then the distance between topics. Like, so there's actually two documents involved, right? I tell ChatGPT, hey, ChatGPT, I want to go grocery shopping today. I don't know what to buy. ChatGPT responds to me, hey, Rena, given your fitness goals, I think you should buy like eggs and bananas, da-da-da-da-da. My prompt and chat's response are each two documents, and we want to know, in the space of all documents, how close are those two documents? That would be called intertopic distance. And I'll just throw some math in since you have a math tattoo on your arm.
Yeah.
Okay. If we're looking on like a 2D Cartesian coordinate space, these two documents should be really, really close together. And we can measure that because it's Euclidean distance. It's literally X and Y. When you find 2 points in space, everybody learned this in grammar school. You know how to measure the distance between 2 points in space, and that's how we can look at the documents, the intertopic distance. And then for one document, identifying the topics and the coherence measure within that topic. That's how I would measure the error of the response from the LLM.
Yeah, right. So fantastic example. I'm doing something that's similar to this with my agents. So I have OpenCode, I have Claude, and I have Codex, and I'm using them for different projects.
No loyalty, just all of them.
Of course not.
Yeah.
And then I set up a plugin for each of those to collect the traces of my conversations and put them into like a central database.
Your conversations with each bot.
Yes.
Cool.
With the bots for certain projects, not for other projects, and then so they're all being deposited into a central database that's local on my computer, and then I trained a loop that looks at the way that I correct the agents, the types of responses that I react to positively in responses.
Looking at your tone.
And the ones, yes. So something that has happened recently for me using Claude is that Claude has this way that it structures sentences. Like it uses a lot of contrastic framing. It jumps to conclusions without necessarily checking or grounding information. Sometimes I've given it tools to go do structured search, and it might do one search and find a result that can be understood as in the direction of what I want to do, but there's a better result and it missed it, right? And so I built myself a rubric of 7 different things that I want to look at.
That you care about. The
Yeah,
metrics
tone
you
of
look for.
voice, the need for correcting the agent, how well did it do search, like recall? Did it find
Like
the
you like
things
the
that I would have
response.
wanted it to find,
Yeah.
or did I have to correct it? Did it use specific constructions in sentences that I've asked it to not do? And so there's a bunch of things, right?
Yeah,
And then I
just
assign some scores to them. I'm using an
scores.
LLM as a
Yes.
judge. There's a weighted sum of these 7 different things.
You weighted it.
Yes, so
Good
like
job.
30%, 25%, like one of them is like
tone is very
5%.
important. Yeah.
Yeah, and then so as new conversations come in, this loop runs again where it looks at some grounding information that I use in my system prompt, and looks at new conversations, and I built a loop that tweaks that grounding information, that system prompt for the agents,
Okay.
and rerun some of those conversations against the same agent,
Yeah.
and measures with an LLM as a judge how well did the scores for each of these 7 buckets, or how did the scores for these 7 buckets move?
Yeah, because it's like a weighted sum that it could just
Yes.
maximize.
And so the inspiration of this came from Andre Carpathy's Art of Research, which is something like this or something similar to this applied to training. And in my case, I'm using it as a way to grade retrieval, for example, or to grade the output of the LLM.
Yeah,
Right?
great
And so
system.
this is the type of thing that I'm saying, right? So there's an ontology at the core of this thing that grounds an agent and gives it a deterministic grading. So run a pass of the extraction over the output of the agent, project it to this ontology or this shape of knowledge, and then run some semantic reasoning on it.
Well, you really thought about the whole process.
And if it improves the score, then that is my new system prompt. And if it
Yeah.
didn't improve the score, then I go back to the old system prompt.
Wow, so you're really making the most out of these agentic coding systems.
There's plenty of things that I haven't tried yet.
Yeah,
but yes,
you're
every
doing
day.
quite a lot. Like I've seen quite a lot of people in the space, and this is the most detail I've heard going through every part of the process, the data that goes into it, the flow diagrams of the ontologies and knowledge management. You're talking about grading how well each one does, how well they understand your tone of voice, and measuring that, optimizing, like the whole process. You've gone into more detail than I've seen anybody else doing.
Oh, well, okay.
Yeah, doing fantastic.
I'll take the compliment.
Yeah.
Definitely lots more to do. Really interesting conversations happening on X around this and on Reddit around this. Yeah.
Yeah, keep going.
I think, well, yeah, I think that the next thing in that direction is, yes, I'm self-hosting some models. I would like to do a bit more research in the direction of which self-hosted models can actually replace some of the cloud models and to what extent.
Yeah.
Yeah.
That's going to be a challenge. Maybe you'll develop one.
I don't know.
If
We'll
anybody
see.
could do it.
We'll see.
Yeah.
Yeah.
2 things I want to call out before we wrap up. One, your hat says
Yes.
agents never sleep.
They never sleep.
Let's talk about your hat real quick.
So this is from the folks at Cloudflare. During React Miami 2026, fantastic team from Cloudflare was there. And I don't know if you've seen, Cloudflare has been on a journey of improving the platform.
Yeah, I heard that they added some AI capabilities when
Yep.
they used to just be like cloud logging.
Yeah, correct. And so they host some of these open source models for you. You can play with their hosted, play or build with their hosted offers.
Yeah.
And like overall great platform. Like I'm
Yeah.
using it for a bunch of things. And
They're,
I like it. We were gonna be talking about AI today, and I figured, hey, agents never sleep.
Perfect.
Yeah.
Yes. Okay, great that you did that.
Yep.
But yeah,
And you said
Cloudflare.
something else?
Another thing I want to call out.
Yeah.
Okay, yeah. You got the Fourier transform equation on your arm. We
I do.
gotta see it.
Oh my God.
We gotta see. I'm gonna show all my friends this.
There you go.
Yeah, all my friends are mathematicians.
Yes. It's a good memento of yes, I vanquished the thing.
Yeah, now math and electrical engineering is just like in your soul.
It is. It's with me till I die.
Body and soul and mind.
Yeah.
Amazing. To wrap up, I am also starting another tradition on the podcast where every guest should make a future forecast of what you think AI will do to the world in the coming years. So make a prediction and put a date time on it, like a year that you think it will happen.
Ooh. Okay. Let's see. I think that by this time next year, how do I quantify this? I think that we're gonna see similar performance to what we see today from self-hosted models coming from models that are half or less the size.
Oh.
So I think that by next year, there's going to be algorithmic advances and hardware advances that make it possible to get the same level of intelligence as we were talking about in the beginning of the conversation from models that take less compute and less space to run.
Yeah, because like we talked about, right now people are experimenting by sort of the brute force method of just massive models, all the data, tons of models. Later they can go in, clean it up, put a nice little strategy, get a mathematician team in there, and really optimize, fine-tune those models, make them smaller. And then the self-hosting concept, you believe that next year people are going to be running these in their living rooms?
But not necessarily the big ones, but for sure that people are going to be able to run models in their phone and in their laptop or like some hardware appliance in their living room that gives them twice or more level of intelligence than what we can do today.
Like maybe install a library on my laptop and run it locally.
Sure. Or maybe, make me some very personal software application without, like fully consumer facing, right? Not necessarily for an engineer without needing to rely on big models.
Yeah. Okay.
I don't know if it's a good prediction, but yeah, I see things going in that direction.
Well, guess what? We can measure it because this time next year we'll see how far the progress was made.
That is correct.
Right now, you're doing it. There could be other people like you.
I'm sure, yeah.
Yeah, so next year, if it becomes as big as vibe coding, or we could at least see, we can't
local models,
measure every person and count it, but we'll just know, And you said this time next year, so 2027 August, we're going to see this happening.
Yeah.
All right. Well, it was great having you on the podcast,
Thank you.
Serge.
Had a lot of fun.
Yeah, it was fun. Great discussions around everything. You can tell people where to follow you if you feel comfortable.
Yes. If you want to, I definitely need to be more diligent in posting. I don't post a lot, but you can find me on all the social media sites as CBNSNDWCH. It's weird, I know. It stands for Cuban sandwich if you take the vowels out. Yes.
Hey, it's okay. Stay weird.
Yeah, yes. I'm mostly active on GitHub and X.
Okay, awesome. Yeah, I'll check out your GitHub too because you have a lot of cool projects going on.
Awesome.
Well, that was this episode of AI Renaissance with Rena, and we will see you in the next one.